pretty.
Steven, do you know?
I think it's the same color.
Do you know something yogurt with rice added?
Oh, I
Yes.
know.
Very terrible taste.
Yes. Very strange. Why do rice mixed
Very
with yogurt?
terrible. Oh my
Yeah, I don't
god.
take this one. I take fruit yogurt, but
Yeah.
not light.
It's delicious.
But light is too light.
Too light is delicious. That's
No, I like
original taste.
heavy yogurt. You know.
No, 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 no. It's ice cream, not
Yeah, like ice cream.
rice.
Yes, yes.
Oh.
Yogurt that's like ice cream. Yes, that's what I like. Okay, we'll continue. So, lecture 2. Oh, be strong.
I'm
Be
alright.
be brave.
我准备打开我这个常温的这个盐。
What do you need?
No, no,
More
no.
She needs
tea?
some, no, she needs some cold water.
Oh. I only had 2 hands.
It's okay.
It's okay. Alright, next.
Thank you very much.
No problem.
My
Resistance.
teacher.
Oh, I know this.
And I'm the best student ever. Thank you.
You're welcome.
Okay, resistance.
Do you eat ramen?
Do I eat what?
Ramen.
Ramen.
Rice.
What meat?
Noodle.
Oh, ramen noodles.
Ramen.
Oh, sometimes.
Sometimes.
Yeah.
Sometimes.
I like Chinese food, yeah.
No.
If do
No?
you usually eat traditional Chinese food?
Not traditional.
Then
Ramen. Ramen.
Irish
I don't know.
Irish takeaway Chinese.
Irish takeaway.
Yeah, not traditional Chinese.
Oh, we never tried Chinese takeaway food.
Uh,
What does it look like?
you probably wouldn't like it.
Why?
What's this?
Maybe it's too different to Chinese food.
How different is it?
It's probably very different.
Like king salad? No, 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 not king salad.
And the noodles are the same, maybe. And the
Rice.
rice. Egg fried rice?
I don't
Yeah,
like
but
rice.
Oh, you don't? I think
the
it's delicious.
material is different.
Maybe, yeah.
The rice.
Ingredients.
Yeah.
It depends on what's inside
Yeah.
the
And
Chinese.
I
Yeah.
heard that in Irish people they cook rice. Just put it in the microwave or put it in the hot water maybe
Hot water.
3 minutes is okay. But actually it's not. So
No.
that's the reason why it's not delicious.
Yes.
We always eat
We don't
rice.
really like rice so much here.
Because we
It's
use
potatoes.
the machine to cook the rice.
Oh, do you? Okay.
Yeah,
The
and
rice
then
cooker.
Oh, you have one of these as well? A rice
yeah,
cooker.
and it could make the rice delicious.
Really?
Yeah,
Okay.
so it's different.
Average I will cook rice maybe for half an hour or 1 hour.
Half an hour or 1 hour?
Yeah.
For rice.
Yeah,
That's how
long
long you cook
time.
rice.
And the rice will taste salty and eat very
Okay.
soft.
Yes,
Yeah.
very.
I will remember this next time I make rice. Because sometimes I make rice and curry, you know, spicy chicken and rice.
How did you make the rice?
Hey, just
Soft.
boil it in hot water for maybe
No, no, no. It's
20
wrong
minutes.
way. It's wrong way.
It's wrong way?
Yeah,
Okay.
yeah. And tastes terrible.
Okay. It's okay.
Okay.
It doesn't taste terrible. It tastes okay.
Last time, if you go to China, please send me email.
I will. I will. Okay. Got this now? So, did you get the title?
Yes.
Resistance. So, you know that current, yeah, like if you remember, where's my pen? If you remember that Q equals IT, so what does I equal? Q over T. So it's the change in the charge over the time. So this is another way to explain current. It's the change in charge per time. Yep. Change of charge. You got that?
Yeah.
It looks like you really need that. Yes. Okay, next. Oh yeah, and you can write it as a formula, but you kind of figured that. Q over T.
Current is I.
Yes. Okay. Now we have some more words. So that's current. Now we have something called voltage. Voltage is electrical potential energy per unit charge. Is measured in joules per coulomb. 1 volt is 1 joule of energy per coulomb. Now I need to explain that with a picture. Got that? Yeah. So, no, okay. Okay. Yep. Okay. So what happens here is, here is the plug, and there's a current. Yes, and maybe you have it connected. I don't know. Maybe it's connected to your TV or something. Whatever. So current I is Q over T. So what's happening is there's a charge moving here, and each time a charge goes into the TV, each time a coulomb goes into the TV can do some work. So when the electrons, they come out here and they go into my phone, each time an electron goes through the phone can do some work, right? If the voltage is 1, that means 1 coulomb can do 1 joule of work. If the voltage is 2, it means 1 coulomb can do 2 joules of work. Okay? So voltage is like how much work your charge can do. Does that make sense? Yeah. So if you want to do more work, do you need a bigger or smaller voltage? Bigger. So if you have 100 volts, then that means 1 coulomb can do 100 joules. Now does anybody know what the voltage is here? It's 220. So that means 1 coulomb, it can do 220 joules of work. Because this is 220. Yeah? And what about your battery, like your battery on your phone? What, do you know the voltage here?
2,400.
No, it's small.
25.
Oh, smaller. Like 4 maybe, yeah. So that means 1 coulomb in the battery can do 4 joules of work. Do we get the idea of voltage?
Yeah.
Yep. Okay. So far we have current and voltage, and the next thing is called resistance. So resistance measures how difficult it is for the current to pass through the conductor. Now, if your English is good, is your English good?
No.
Maybe you know this word in English, resistance. You do know this word. Then your English is good. Congratulations.
What is conductor?
Conductor.
Yeah.
Okay. Yeah, conductor like a metal. It's easy for the electricity to go through it. You know this from chemistry? Conductor and insulator. So, this is a conductor. This is an insulator.
Ah, yes.
You know resistance, but you don't know conductor.
That's what
Okay.
easy to remember.
Very easy. Too easy.
Maybe this is not my word.
No, maybe not.
Somebody else.
Maybe somebody else's. Maybe Sophie's. Where is Sophie?
Sleepy. Maybe sleepy.
Maybe sleeping?
And wake up is 10 o'clock.
Yes. 11 o'clock maybe.
And we have traffic here.
Is Sophie in a homestay?
Yes.
Irish family?
Yes.
Maybe I
No,
don't know.
like Irish.
Irish family?
Local people.
Local people.
Mm.
Does she like it?
We didn't ask.
Okay.
Maybe she likes.
Maybe she likes. Okay.
Maybe she likes.
Okay, so the unit is called the ohm, and 1 ohm means 1 volt was converted into energy when 1 amp passes through the
Can you
resistor.
write down everything?
Unfortunately, yes.
Converted.
Yeah, so the ohm, 1 ohm means 1 volt of electrical energy was converted into another form of energy when 1 amp was passed through the resistor. So let me just draw that before you write it down. So for example here is 1 amp, and here is my TV, and if 1 joule per coulomb of work was done, so for example here is my coulombs, they did some work, and then later, can they still do work? No, because they did the work here. So it's like they can't do more work because they already did the work at the TV. Does that make sense? Like, it's like they're tired.
Yes.
So we say that the resistance is 1 ohm. That if you have 1 amp and 1 joule per coulomb of work was done, then it's like each coulomb, it got tired. It can't do the work anymore. Yeah? So your glasses.
Yes. Very hot. Oh my god.
They're all steamy.
Yes.
So this is resistance. It's like the coulombs of charge. They did the work and then they can't do more work. So if this is very big, like if it was 4, it means 4 joules per coulomb of work was done. So for example, 10 ohms, that means 10 joules per coulomb of work was done. Okay? Now, I know this definition seems a little bit confusing, but think about it like this. If this is bigger, it means more work was done. Simple as that. So, I'll say that again. Listen carefully. If resistance was bigger, it means more work was done. Um, so what would have a bigger resistance? A TV or a cooker? An
TV.
oven?
TV.
No,
Cooker.
cooker, an oven. You do more work when you cook food. There's more energy used. What do you think would have more resistance? Your laptop or your phone?
Laptop.
Laptop, more resistance. And finally, what would have more resistance? A light bulb or shower, electric shower,
Light
Electric.
bulb?
electric shower.
Why? Because heating?
Yeah, lot of work to heat. Heat and water, lots of work, lots of work. In fact, in your home, the electric shower, if you have an electric shower, uses the most, it does the most work. Is your showers electric or gas, or you don't know?
Electric.
Gas in accommodation or
Yeah. Accommodation?
as in at home in Malaysia or regular?
Yeah. You can usually tell if it's electric or gas. So with a gas shower, the water comes out very fast, but with an electric shower, the water doesn't come out too fast.
To cool maybe 1 hour.
And the other thing is, with an electric shower, the water is always hot. With a gas shower, sometimes the water is not hot.
Yeah, I use a gas shower.
Okay, because sometimes the water is not hot.
I mean if I think it's normal, right? Like if you leave the heater on for a
Yeah,
long
yeah, yeah.
time.
Yeah, if you leave the water on for a long time, then there's no hot water left. But with an electric shower, the water gets heated as it's being used,
Okay.
so it's always hot.
My home use gas.
So sometimes the water is
No,
cold.
electric.
Yes.
Uh,
Gas. Okay.
in here it's electric.
Probably.
In home.
Yeah.
And maybe no
In
no.
China.
In China it's gas.
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 Yes. Here is electric.
Yeah.
Yes. Electric I like because it's always hot.
Mhm.
Whereas gas, sometimes you have no hot water left.
But electric has the sound.
Yeah, it's noisier. You can hear it.
Oh, it's outside my home.
Yes. What? The shower?
Gas.
The gas? Gas, yes. Yes. Okay, continue?
Yes.
Okay. So the following picture might help with the relationship. Maybe you remember this picture. You remember this picture?
Mm.
Between V, I and R.
Amazing teacher.
So, the resistance is trying to stop the current. Yes? And the voltage is what's doing the work. So if the voltage is very big, it means more work per coulomb. If the resistance is very big, it's making the charge harder. It can do less work. Anyways, you don't need to write that down. I just want you to understand that if he is big, it makes his job, makes him tireder. He can do less work. But if he is big, it is okay if he is
Also big.
strong. Yeah. Of course, a lot of voltage can do a lot of work because 200 volts means 200 joules per coulomb. So if he is strong, then he will need to be big. Yeah? Anyways, I thought that picture was funny. How can we measure voltage? Well, we use a
Oh.
voltmeter. That's how we measure voltage. You might want to write that word down. That's what a voltmeter looks like. We can measure voltage using a voltmeter. Now that's an old-fashioned voltmeter. That's what my physics teacher used. You will not use this. You'll use a digital one. But I think these look cooler. Doesn't it?
I like
Yeah. Looks, has a kind of nice old-fashioned look about it. You know? So the voltage is on the screen here. How do you think you measure current? And don't say current meter. What's the unit for current? Amp.
Ammeter.
So we measure current using an ammeter. Yeah, the P gets dropped. Ammeter. Hey, look, it's the same. Ammeter. You had these in high school?
Yeah.
Or just like this?
Yeah,
Yes,
this
Nice.
very
back
old
in the
one.
day.
Very old one, nice. I like the old ones. You had digital?
Yeah, both of them.
Oh, you both, okay. Have you used
This
this?
one, yeah, we already have this.
Traditional one.
Yeah,
Traditional ammeter.
yeah.
We
Yes?
have this one in museum.
Yes, yes, yes.
It was then, it is like that.
Yeah, I mean, they just look nice. I like how they look. Okay, next one. So how do you think you measure resistance?
Using one meter.
Use
I
the
know, what machine could you use?
use the
Ohmmeter.
Ohmmeter.
like an ohmmeter.
Yeah. Now wait, listen carefully. This machine is not accurate. So we don't usually use it. It's not accurate. We will learn, like you said, Amanda, we usually use the formula to calculate it. But it is possible to measure resistance using something called a ohmmeter. But it's not accurate. It's very inaccurate. But please write the names down. They're good for your English. Voltmeter, ammeter, ohmmeter. Yeah? Got that? Yeah. Continue? Yes? We will not use an ohmmeter. We will use a voltmeter and an ammeter. We won't do questions with an ohmmeter. We'll only do questions with a voltmeter and an ammeter. Yeah? Okay. An ammeter requires a current to flow through it. A voltmeter measures voltage between 2 points. So I need to I think I'll draw what I mean here. So if we just look here, if you want to measure the current here, you just stick an ammeter right here to measure the current. And then it will tell you 10 amps on the screen. But this is not how voltage works. So imagine here we have a TV, and we want to know the voltage. Now remember, 1 volt equals 1 joule per coulomb. So when you want to measure voltage, it's like you want to measure how much work was done. So you must firstly put the voltmeter around something which is doing work. So if it said 200 volts, what that means is every time 1 coulomb went through the TV, the 1 coulomb did 200 joules of work. So the voltmeter must go around a resistance, a resistor. Whereas an ammeter, you can just put it in the wire. Yeah. So a voltmeter must go around something, but an ammeter you can just go straight through it. Never do this. Never. You never put a voltmeter in the middle like this. Okay. Now if you need to make a note of that, please do, because it is important. So this is forbidden.
What happened with this?
You won't get the result.
It'll probably just say 0 on the screen. Or error. You know. Some digital voltmeters can be used this way, but in special situations, which we'll talk about later.
Yeah.
But for the moment, we can't usually do this.
Yeah.
But there is one important exception, which I'll surprise you next week with, okay? Okay, can I go back to the slides? Yep. Right. That should say triangle, not triangel. This will explain the relationship between V, I, and OR. Wait, before you write this down, this triangle is like what other triangle you've seen before?
And then
Yeah, the distance, speed, time.
Mm.
So if you know the voltage and the current, you can know the resistance. If you know the resistance, you can know the voltage and the current. And if you know the current, you can know the voltage. Sorry, if you know the voltage and the current, you can know the resistance. So for example, what's the formula for voltage?
I times R.
I
I or. And what's the formula for I?
V over R.
And or?
V over
V over I.
Something like
So we can relate the tree together with this triangle. Have you got this triangle?
yeah.
Yep.
Mhm.
Yeah.
Yeah.
Continue?
Yeah.
Yeah. Okay, so let's have a look at our first question. How many questions have I got? I've got two questions. Now you listen, I don't need you to write all of this down. What you could do is just read it and then write down the VIR. Yeah. So let's read it together. An ammeter measures 250 milliamps. The voltmeter measures how much? 220 volts. What is the resistance? Do you want to write the question down or just the information?
Information.
Okay, good. So let me draw this. You want to write it down, Grace? Okay. So have a look.
I don't know how to write it.
I'll draw it for you. So what you have is you have your light bulb. You know what I mean, don't you?
Yes.
And here's the current, ammeter. So the ammeter says current is, what did I say? 250 milliamps. And what else do I tell you?
Voltage.
I tell you the voltage. So look, I must draw my voltage, my voltmeter like this. Voltage equals
I
250.
220 volts.
220.
So what's the formula for I if I use my triangle?
I equals V over R.
Yeah, 0.250 because it's milliamps.
But they want to find the R, not the I.
Oh, sorry. Of course, sorry. What's the formula for or?
V over I.
It's V over I, which is 220 over 0.250. That's what I just wrote, wasn't it? 220 divided by 0.250, which is 880 ohms.
Oh, 180.
Yeah, it is, isn't it? Next question, last question. Okay, so again, you don't need to write it down if you can draw it. If you can draw it. So I'll let you read it or write it and then draw it. That should say if the tie is left on. Yeah, so we got a lot done today. 3 homeworks and 1 new topic. Oh, it's great. Ah, that's fantastic.
How many electrons flow is the current actually? Charge means.
Yeah,
How many electrons flow?
yeah, I'll have to fix this. Anyway, can I do it now?
No.
No, you want to write the English down, yeah?
Yeah.
Okay. That's a typo. Look, that should say if the toy is left on for 1 minute. Yes? Not yet. Time to do it?
Yes.
Right. So, tell me what information you know. Well, you know that the battery, let me try and draw a little battery for you. This is a 2-volt battery. And it's connected to a toy. What's the toy? It doesn't matter. We'll say the toy is a Pikachu. Or what else could it be?
You can draw Lionel.
I'll try and draw a Pikachu. Yeah. How do I? And he's got like this, and he's got some.
Oh, terrible.
A Doraemon.
Looks like
Doraemon.
Pikachu.
No, it doesn't look like a Pikachu at all, does it? That's not too bad.
Why you don't draw Hello Kitty? It's easy than Pikachu.
Who should I draw?
Hello Kitty.
No, don't like Hello Kitty. Right, now so this Pikachu toy or whatever it is, it has a resistance of 2 ohms. Oh sorry, it's not 2 volts, it's 6 volts.
Yeah.
6 volts, but it's 2 ohms resistance. Okay, so what is the current I? Yeah, so what formula did you use? Let me see, VIR. So you said I equals V over R, 6 over 2, 3 amps. Yep. I like my Pikachu. Okay, so that's fine, yeah? Now the next one is if you left the toy on for 1 minute, how many electrons would go through the Pikachu? Right, so what's the formula we need here? We need to use Q equals IT. What's the I? 3. And what's the T? 60. So it's 180 coulombs. Is that 180 electrons?
No.
No. How can I get the number of electrons?
Multiply by 180
No.
Cool.
180 coulombs divided by
Work.
no. How much charge is in 1 electron? So 1 electron is only 1.6 times 10 to the minus 19 coulombs. So you have many electrons to make this charge. One .13 times 10 to the 21 electrons. So a lot of electrons went through the toy in 1 minute. Yeah? I gave you this number last time. It's called E. It's the charge of one electron. Lastly, if I change this to 12 volts and this stays the same, what happens to the I? Well, what's the formula for I? I equals V over R. What's the V? 12. What's the R? 2. So what happens to the I? 6, isn't it? 6 amps. Yeah.
That's all right.
Huh?
Is that all?
I think so. That's the last one. Now please note the important message at the end. Wait. I said we assume that the resistance is constant. So do you see here in this picture the resistance is 2, and then if I replace this with 12, I said it's still 2. Now that's usually but not always true. Okay? This should change also when this changes, but often the change is so small that we say it's the same. And this is something we'll see later again. Okay, homework there. So, again, this homework is quite short, like the last homework. No, the last homework with charge was quite short, so I don't think it'll take you too long to do this.
Is it finished?
Is it finished? It is.